Yeah. Okay. Alright. There we go. Okay, so look. Let me tell you about this here circuit. I've been messing with this thing. I'm trying to get it right. I'm going to do some drainage of these capacitors. They're not draining quick enough. In fact, I kind of want a little bit of drainage. So I'm going to use a resistor and give it a try to see if that can reduce some of the drainage. And then I'm going to explain what the hell you're looking at, because it's a mess. And there we go. Is it still working? Yes. Yes. Kind of. Let me turn the volume up. How about that? Check a 1. Check 1. Check. Oh, that's what. It's working. That's a 10K. Let's try something a little bit more resistance. We don't want to lose quite so much power. I want to double that. And I have just the one sitting right on top as a 27K. Probably a little bit more resistance than necessary. But we're trying to drain that cap when not being used. Check 1, check 1, test 1. Yeah. Alright. Cool. Now, to what you're looking at, I'm turn this light, that's stupid. Okay, so what you're looking at, this is a condenser microphone capsule. And it's going through, let me grab a pointer that's not made of metal. Okay. So, very carefully, it's going from this mic cap. It's grounded from this black cord, of course. That doesn't really matter. But the other leg, one of the legs of this condenser mic goes into this cap and this resistor. This cap jumps over to this transistor here. And then this resistor connects the base and the collector together. This resistor connects voltage to the collector. This is the output cap here on the tip of my pen. This little doodad here, little guy. And again, we just put this grounding resistor to shed some voltage because these caps were storing too much power and I couldn't stand that. That's going to bug me. And then of course the emitter is gathering current here. This is how you amplify a microphone signal. This yellow wire comes off of the output capacitor. Orange, holy crud, orange wire comes across and goes into, I have this schematic up, okay, it comes into here, pin 5, but down here you can't really see that, so I have the schematic up here on my deck, and this was covered in another video, so I'm not going to cover it again, but I'm going to turn my light off so you can see what's happening. Alright, so we're going to get down here on this meter, and when we talk, now we have us an ambient room voltage audio, it's called an audio spectrum analyzer, or a VU meter. Ooh, I like that. Yes, check 1, check, test 1. I'm such a nerd, I'm sorry. But look, see, look, now we could sit here, and if I turn this the way it is now, the sensitivity is not totally messed up, but now when I talk to you, I could just kind of lean over near my microphone, right, and start talking, and you'll see my voice on a like visual side of things. It's so blurry. There it is. Ooh, I love it. I'm just sit here. Yeah, check, 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 check. Bored at 4. What time is it? It's 2 something. It's 2 something in the morning. Oh, I love this thing so much, and I'm not even using the full 9 volts. And if I put this on a 9-volt battery, you don't understand. This thing is a portable little pocket audio spectrum analyzer. When I'm out in public, if that thing starts getting into the yellows and reds, that's too loud for me, because this is my normal speaking voice, and it's jumping up there to the top of the green. And if I get right down on that microphone, if I start hollering in that microphone, it starts getting really red really fast. Really, really red really, really fast. Okay, so this has been... I've destroyed my workbench. And look, the preamp that I was building, the preamp for the microphone, I don't think is going to fit on here. Now that I'm looking at this board versus how much it took. I had to bias that transistor to make it work like this. And in fact, if it weren't for that voltage drain resistor, it wouldn't even be functioning as good as it is now. So, hot snot, man, that's bad. That's bad to the bone. I don't want to say too much on, because I'm going to put this one on YouTube. I'm stoked. Like, I've been tinkering with this for the last, okay, really not that long. Maybe like 30 minutes. But 30 minutes later, I have a working ambient sound sensor. And here's the reason that's amazing. If I set up an output and a certain voltage threshold is met, let's say somebody breaks the glass or snaps their fingers and it pops all the way up there to the red, I could have it set off an alarm. That last, very last red one would be louder than a thump right up next to the mic. And I could rig up another transistor preamp and have that amplifier switch an alarm or something like that. I mean, just to tell you, this is not useless. This VU meter can be used for more than just dancing pretty lights, which I'm not going to lie. That is exactly why I built it, was the dancing pretty lights. But now that I'm looking at just about how much voltage and sound it takes to set this thing off, like if I tap the mic, I mean, it goes off the chart. It's so sensitive. And then, of course, this right here, I can dial it down to where it's not quite so sensitive, so you'd have to, even thumping wouldn't be that loud. So, I mean, I've got it set all the way up because I'm sitting here talking to it by myself at 2 in the morning. Okay, this has been a very interesting experiment. Alright, okay, bye. This has been Dave's Workbench. I'm sorry. I'm not sorry, but look, it works, right? It works. That's what matters. We made something that works. Okay, I'm sorry. I'm done.